The Ulu-Jalai hydroelectric project is located in the Cameron Highlands in the state of Pahang, some 140 kilometers north of Kuala Lumpur. The hydropower scheme collects the water flow of 3 rivers, the Bertam, the Telom and the Lemoy, by means of one main RCC dam and 2 weirs, and conveys it through a system of tunnels to an underground cavern powerhouse with 372 megawatts installed capacity. The Suzu Dam, in roller-compacted concrete, 88 meters high, with an 850,000 cubic meters volume of RCC, will be located in the central valley of the Bertam River and will create a reservoir of about 25 million cubic meters capacity. The 2 concrete weirs on the Telom and Lemoy rivers will be equipped with water intakes to divert the river's flow to the Suzu reservoir by means of 2 16 kilometers long transfer tunnels. The Suzu Dam will have a central concrete structure incorporating the temporary diversion works and the low-level outlet sluice, both equipped with hydromechanical gates and the ungated spillway. The intake tower, with 3 power intakes equipped with hydromechanical works conveying the water to the headrace tunnel, will be located on the right-hand bank of the Suzu Dam. The headrace tunnel will transfer the water to a 400 meters high vertical shaft and through the power tunnel and the penstocks to the powerhouse cavern, housing 2 186 megawatts Francis turbines. After power generation, the water flows through the surge chamber, equipped with control gates, to the tail race tunnel and back to the riverbed. The project globally involves about 25 kilometers of tunneling works. The overall volume of external excavations amounts to about 5 million cubic meters, and the total volume of concrete works to almost 400,000 cubic meters. Work is due to commence in May 2011. The time frame foreseen for the execution of the construction work is 62 months, which is in accordance with the employer's requirement to start power generation by July 2016. 62 months is an extremely challenging time frame for such a complex and articulated project. This obliges carrying out construction work on 9 contemporary underground fronts and 5 contemporary external fronts, all at the same time, involving the deployment of very important resources in terms of plant, equipment and personnel, as well as requiring particularly attentive planning of the activities and high skill for their implementation. Even more so, considering some of the significant design constraints and stringent technical specifications that will be further illustrated. For the construction of the Suzu Dam, the quarry, located downstream from the dam toe, will supply all the rock for the RCC as well as for the conventional concrete. The blasted rock will be transported to the crushing plant by means of 40 tons dumpers. A twin-line primary and secondary crusher will crush the blasted rock and feed it through an underground conveyor belt to the third crushing plant for the fabrication of the RCC aggregates, which will be transferred to the cooling silos of the RCC batching plant by means of a system of conveyor belts. Cooling of the aggregates in the silos is necessary in order to meet the RCC temperature requirements according to the technical specifications. A system of conveyor belts with a total length of 2 kilometers will transport the RCC to the dam and distribute and place it in the different areas. According to the technical specifications, transport of the RCC with dumpers is very limited. This implies the use of a quite sophisticated system of distributing conveyor belts, also assisted by movable belts on trucks. For the conventional concrete structures, the spillway and the intake tower, another third crushing plant will be necessary to prepare the aggregates. These will be transported to a batching plant at the dam toe, equipped with an ice plant, necessary to comply with the stringent technical specifications concerning the concrete temperature.